Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we will study about the 8255 Programmable Peripheral Interface, its block diagram and pin description. So let's start with our topic. We have the Programmable Peripheral Interface and the IC number for this is 8255. Okay. So this Programmable Peripheral Interface, it is a general purpose programmable input output device. This 8255, it is known as Programmable Peripheral Interface. So programmable means that this can be programmed. We can write programs in this 8255. And a peripheral means that input output device, and interface means a path which is providing the communication between two components. Okay, so this 8255, it is a programmable device which is a programmable input output device, and this device can act as an interface between the microprocessors and the other devices. Okay, so if we say this 8255, it is a general purpose programmable input output device. We are saying that this is a programmable peripheral interface. So we are saying that it's a programmable device. So it means that it can transfer the data under various types of conditions, like from simple input output device to the interrupt input output device. It means it is acting as an communication path between the processors, microprocessors, so that they can have interaction with each other. Okay. Now this 8255 microprocessor, it is very flexible, it is versatile, and it's very economical, but its circuitry is somewhat complex. So we can say that 8255, it is flexible, versatile, economical, but somewhat complex. So these were little bit features of the 8255 microprocessor, this 8255 programmable peripheral interface. Now let's see that what are the features of this. This 8255 programmable peripheral interface PPI, it has 24 input output lines. And these 24 input output lines, they are divided into 3 ports. Okay, these ports are input output ports, and they are named as port A, port B and port C. So 24 input output lines divided into 3 input output ports. So each port will have 8 lines. And these lines can be used as either input lines or the output lines. Okay. Now the port A and port B, they have one 8-bit output and input buffer associated with it, whereas port C don't have any buffer associated with it. Also, the 8 lines of this port C, they can be divided into 4 lines. So 4 lines, they are known as the C upper and C lower. So if we denote the 8 lines of all these 4 ports, then for port A we will have A0 to A7. For port B we will have B0 to B7. And for port C we will have C0 to C7. Okay. Now these are the ports, so its suffix we are writing here as PA0, PA7, then PB0, PB7, and PC0 and PC7 to denote that these are the ports. Okay. Now PC0, PC7, they are these 8 lines, they are further divided into 4 lines. So C upper and C lower, we will have PC0 to PC3 and PC4 to PC7. So we have the 8255, we have 24 input output lines which are divided into 3 ports, port A, B and C, and port C is further divided into 4 lines ports which are C upper and C lower. Okay. Now these ports, they are grouped into 2, group A and group B. Group A has port A and C upper, and group B has port B and port C lower. Okay. So port A, it has 8 lines, then it has 4 lines, it also has 8 lines, and these are the 4 lines. So 12 lines are available in each of the groups, group A and group B. If we draw the diagram here for it, then it will be like we have the 8255. Let's draw it here. So if we draw the diagram for it, the ports, how we can describe it, we will have 8255, port A, this is C upper, C lower, and then port B. This is port C. Okay. So port A and C upper, they are forming the group A, and C lower and port B, they are forming the group B. Okay. Now these ports, they can be programmed either as an input port or either as a output port. And this description that how we are using the ports, whether as an input or output port, it is decided by the modes of the 8255. There are different types of modes, so those modes define that which port will be used as an input port and which port will be used as an output port. So the two groups of the ports, group A and B, they can be programmed in different modes. And in 8255 we have 2 modes, bit set reset mode and the other is input output mode. So there are two modes, bit set reset mode and input output mode. This mode, bit set reset mode, it decides that which bits are to be set and which are to be reset. Whereas the input output mode, it will decide that which port is going to be used as an input port and which port is going to be used as an output port. And the input output mode, it is further divided into three modes, mode 0, 1 and 2. So input output mode, we have mode 0, 1 and 2. We are going to study these modes of 8255 in our other video. Okay. So now let's come to the pin diagram of 82. We have the diagram for the pin description. Because it's a 40 pin IC. So these are the 40 pins, denoting all the pin names are written over here. Now if you can see that this pin number 1, 2, 3, 4, they are denoted as PA3, PA2, PA1 and PA0. So these are the 4 lines of the port A. Then we have RD bar. This is the read input. Then CS, it is chip select. GND, this is for the ground connection. A1 and A0, these are the port addresses. Okay, which port is to be selected and in which mode it is selected, then these are decided by the A0 and A1. So we can say that these are the port addresses. They decide the address of the port, that which port out of port A, B and C has to be selected. Then PC7 to PC4, it is port C upper. Then PC0 to PC3, it is port C lower. Then PB0, PB1, PB2, PB3 till PB7, these are the port B. Then VCC, it is the power supply, which is plus 5 volt. Then we have D0 till D7, the data bus. Then reset signal, WR bar, it is the write input. And P4 to P7, it is port A. So this is how the 40 pins of the 8255 programmable peripheral interface, they are described. Okay, so let's start again. We have the 40 pins from 1 to 20, then 21 to 40. We have 3 ports in 8255, so each port have 8 pins. So we have 4 pins for port A, then 4 pins for port A here from 37 to 40. Then we have the read, chip select, ground, A0, A1 and VCC, reset and WR. RD is for the read input, WR bar, it is for the write input. Then chip select, then ground sig is there. Ground and VCC are the power supply pins and reset is there. Okay, so let us study one by one the description of all the pins of 8255. First, we will start with the chip select, that is CS. So chip selects this pin, it is used to select the chip. Means if we want to use the 8255 programmable peripheral interface, then we have to select this chip, this IC, and this chip will be selected when this chip select pin it is low, because we are having CS bar over it, so it's an active low signal, means it is active when its value is 0. So a low on this input, it will select the chip and enables the communication between the 8255 and the central processing unit of the microprocessor. So here if we see, this is our microprocessor MUPI. Here we have the 8255 and here we have the input output devices. So this, if we have selected the chip, then it will enable the communication between the microprocessor and the 8255. When on this chip select signal, it is low is provided, then the communication will be performed. So this is the use of chip select signal. Next we have RD bar, which is on pin number 5, which is the read input. So this is read input, and when this signal is low, because we are having bar over it, so it's again an active low signal. So when this signal is low, 8255 will send out data or status, or it is or we can say that it is sending the information to the CPU on the data bus. It is providing the information to the central processing unit, and it is putting the data on the, or sending out the data on the data bus. Okay, then we have read. So when this write input, we are having a low on this input pin, then it will enable the central processing unit to write the data or control word into the 8255. So if we have here the CPU and it is the 8255, and we have the two signals, RD bar and write. So when read is there, then the 8255 will send the data to the on the data bus of the CPU, and when write is there, then CPU it is going to write the data or the control word into the 8255. The next pins we have are A1 and A0. These pins A1 and A0, they are known as the port select pins. So these pins, in conjunction with the read signal and the write signal, means A1, A0, read and write, they decide that which of the port is selected by the control word. Okay, let's see the table for it. We have A1, A0, RD bar, WR bar and chip select signal. as I have said that A1, A0 and read and write, these 4 pins, they are going to decide that which port is going to be selected. So when the value of A1 and A0 both is 0 and the read signal, the read pin, it is 0, means it is activated. Write is 1, means it's not activated, and chip select signal, it has to be 0 for all the operations, then only the chip 8255 will be selected. So when A1 and A0 both are 0, then port A is selected and the data on the port A, it is given on the data bus. So this is an input operation. Means the port A, it is giving an input to the data bus. Then A1 is 0, A0 is 1, then port B will be selected and it's a read operation. So port B, it is going to read the data, port B will be read by the data bus. Okay. Then A1 is 1 and A0 is 0. So port C will be selected and it's a read operation. So data bus, it is going to read the data from the port C. So data bus, it is getting the input from the 3 ports. Okay, so this is describing the input operation. Now again 0 0, so port A will be selected and the data which is available on the data bus, it is given on port A. So this will be an output operation. Okay, so these 3 are the output operation. Then A1 is 0 and A0 is 1, then port B is selected. When A1 and A0, it's 1 and 0, then port C is selected. So the data which is available on the data bus, it is given on the 3 ports. So it's an output operation. So we can say that when A1 and A0, they are 0 0, then port A is selected. When they are 0 1, then port B is selected, and when they are 1 0, then port C is selected. Okay. Now when the value of this A1 and A0, it is 1 1, then control register is going to be selected. Okay, so when its value is 1 1, it's a read operation. Then data bus, it is going to give the data which is available on the data bus, it will be loaded into the control register. Okay, so because its read is 1 and write is 0, so that data will be written on the control register. Okay, so we can say that these 2 pins, port select pins, they are used to select the 3 ports A, B and C. Next in the pin diagram, we have studied read, we have chip select signal, ground and power supply, they are the power supply pins. Ground is connected to the earth and VCC, it is connected to the plus 5 volts power supply. We are left with this reset pin. Okay, so reset pin, it is used to clear the control register. As I have said that there are various modes in which the 8255 works, and these modes, which mode is going to be work, it is decided by the control word which is written in the control register. Now if we want to clear the contents of the control register, then this reset pin is used. So this reset pin, when it is high on this input pin, it will clear the control registers, and all the ports A, B and C, they are initialized to the input mode. That means they will act as an input ports. And this pin, it is connected to the reset out pin of the microprocessor, and this is done to prevent the destruction of the circuitry which is connected to the port lines. Why we are clearing out this? Because we want to prevent the damage of the circuitry which is connected to the port lines. Okay, so the main purpose of this reset pin, it is to clear the control register and to initialize all the ports in the input mode. So this was the reset pin. So in this pin diagram, we have the port A, which is the 8-bit port, and port B and port C, which are also 8-bit ports, and port C, it is divided into 4-bit ports: port A, port C upper and port C lower. And the other pins which we have which are present in this pin diagram, we have discussed. So we have completed this pin description of the 8255, this pin diagram. Now let's come to the block diagram of 8255. This is the block diagram of 8255 programmable peripheral interface. In this block diagram, you can see that you have two parts here: group A control and group B control. In group A, we have the port A and the port C upper. You can see that group A control, it is controlling the group A port C upper, the 4 lines which are from PC7 to PC4, and also the group A port A, which is having 8 lines, PA0 to PA7. Okay. Then we have the group B control, which is having port B and port C lower. Port B, it is having 8 lines here, and the 8 lines of this are from PB0 to PB7. Then port C lower, we have PC3 to PC0. Okay, so these two ports, they are controlled by this group B control, and these two group A, this port A and port C upper, they are controlled by the group A control. The lines are going to each of the ports. Okay, then we have an internal 8-bit data bus. Okay, and this data bus, it is connected to all the ports. The data can be read from the data bus, and also the data from the ports can be written on the data bus. Okay, so we have this 8-bit internal data bus which is connected with the controls also and to all the ports. Now these ports, they can act as an input output ports. So we have these bidirectional lines here which is showing that they can be used as an input output ports depending upon the modes. Now here we have this data bus. It has a data bus buffer, and this data bus is bidirectional from D0 to D7. Then we have read-write control logic, and to this read-write control logic we have the various signals which decide that whether the operation, it is a read operation or it's a write operation. We have the signals read, write, A1, A0, which will decide that which port is going to be selected. Then we have the reset signal here, reset pin, which is going to clear the control register. Then we have the chip select signal here, which is will decide that if it is low, then this 8255 chip will be selected, otherwise it will not be selected. It will not allow the communication between the central processing unit and between the data bus. Okay, so this is the block diagram representing all the blocks or all the components of 8255. Now let us study each of these blocks, each of these components one by one. We will start with the ports A, B and C. As we have studied earlier that these ports are 8-bit in ports and they can be used as either input port or output port. First we will have port A. This port A is having one 8-bit data output latch or buffer and one 8-bit input latch. Okay, so input latch, it is providing the input data, and output latch, it is providing the output data. So when the port it is acting as an output port, this latch will work, and when this port is acting as an input port, then this input latch is going to work. Then we have port B. Port B also have one 8-bit data output latch which will be used when the port will act as an output port, and one 8-bit input buffer which will be active when the port will act as an input port. Similarly, we have port C. Port C also have one 8-bit data output latch and buffer and one 8-bit input buffer. Okay, so these three ports are available in the 8255, and for each port we have an output latch and an input latch. Okay. Now next we have the group A and group B control. So the functional configuration of each port, it is programmed by the system software. We have three ports and each of the port can act as an input port and output port. So this function, that whether the port will act as an input or output, it is decided by the control word which is written in the control register. So the functional configuration of each port, it is programmed by the system software. So the control word which is written in the control register, it is given by the CPU. It configures the associated ports of each of the two groups, because we have group A and group B. Group B is having the port A and the port C upper. So the control word which is written in the control register, that will decide that which group is going to be active. Okay, so the control word, it is which is outputted by the CPU, it will configure the associated ports. Okay, and which information, the information which is carried by the control word, it contains the mode, set, reset bits, and which mode is going to be selected, and which data bit is which port will act as an input, which is going to be act as output, and which group is going to be active. All the information, it is contained in the control word. So the control word, it contains all the important information like the mode, set, reset. Then this information, it initializes the functional configuration, or we can say that this control word decides that the ports of the 8255, they will work in which of the modes. Now this control word, it is provided by the CPU of the microprocessor, and the CPU is going to write this control word into the control register. So for the control register, we have the write signal, and the control register, it cannot be read by the microprocessor, so it has only the write signal associated with it. So this was about the group A and group B control. Group A was having the port A and the port C upper, and group B contains the port B and the port C lower. Now comes in the block diagram, we have the next block, that is the data bus buffer and the bidirectional data bus. The 8255, it is having the internal 8-bit data bus is also there, and with this internal data bus, it has the data bus buffer. Now this data bus buffer, it is an 8-bit bidirectional buffer, and it is a tri-state 8-bit buffer which is used to communicate with the data bus of the microprocessor. So whatever data, if the data is to be written into the ports A, B and C, or in the control register, then that data is provided by the CPU of the microprocessor into the data bus buffer. And when the data is read from the ports A, B, C, then that data is also transferred through the internal data bus onto the data bus buffer. So the work of this data bus buffer is to communicate with the central processing unit of the microprocessor, and also with the 8255. So it's a communication link which is transferring the data between the 8255 and the microprocessor. So we can say that the data bus buffer, it is a tri-state It is a tri-state 8-bit buffer because data bus is of 8 bits, so the buffer has to be of 8 bits. So it's a tri-state 8-bit buffer which is used to interface the chip to the system data bus. Interface, it is a communication link between two components. So we can say that the data bus buffer, it is acting as an interface between the chip, that is the 8255, and the system data bus, that is the data bus of the microprocessor. Now, as this data bus buffer, it is transmitting or receiving the data. So this data is transmitted or received when the instructions in and out are executed by the CPU of the microprocessor. Now, this data bus buffer, it will read the data from which is on the ports. If this read signal, it is low, and the instruction in is given by the central processing unit of the microprocessor. So in instruction, it is going to read the data from the ports, and if the CPU has given the instructor or it has executed the instruction out and this write signal it is low, then the data which is available on the data bus buffer, it will be written on the ports A, B and C, or if it is the control word, then the control word will be written in the control register. So that is the function of the data bus, that the data is transmitted or received when the instructions in and out are executed, and when the signals read and write are at their appropriate logic. Okay. Not only the data which is transmitted or received by the buffer, the control word is also, and the status words, they are also sent out by the data bus buffer. If the control register is selected, then the data bus buffer, the data which is provided by the CPU of the microprocessor, that control word will be written in the control register. So the data and the control and the status informations, all such type of informations, they are transmitted or received by the data bus buffer. Now next in the block diagram comes the read and write control logic. Now this read and write control logic, it is having these 5 signals: read, write, A1, A0, reset and chip select. We have already studied these signals, that what is the function of these signals. Read signal, it is used to read the data from the ports. Write is used to write the control word or write the data onto the ports. Then A1 and A0, they are used to select the port, that is the port addresses, they are decided by A1 and A0. And reset is used to clear all the ports, and chip the select, this signal, it is used to select the chip 8255. So this read and write control logic, its function is to control all the functions which are performed by the chip 8255. So the function of this read and write control logic, it is to control the internal operation of the device, that is the 8255, and to control the transfer of data and control of status word. So whatever data it is read or written, that is read from the ports and written into the ports and the control register, all those information, it is controlled by the read and write control logic. Now this read and write control logic, it accepts the inputs from the CPU address and the control buses. The address of the ports, it is getting from the address bus of the CPU of microprocessor, and control buses, from the control buses it is getting the control signals read and write. And in turn it is issuing the commands to both the control groups, group A control and group B control. Okay. So that is the function of all the blocks of this block diagram of 8255. we know that this power supply, it is provided by the plus 5 volts and ground. Then we have the group A control, group B control. Group A control is having port A and the port C upper. These are the internal data buses which are transferring the data to the all the blocks, and the single lines, they are showing the control signals which are given to all the ports and the group A control and group B control. The bidirectional buses, they are showing, these are the internal data buses, and the single lines, these are the internal control bus. Okay, control signals are transmitted through these. Now these groups, the ports, they can act as an input output ports. So they have the pins, because they are 8-bit ports, so they have the pins PA7 to PA0, like PC7 PC4, because it is port C upper, then port C lower, PC0 PC3, and port B PB7 to PB0. And all these 4 ports, they can act as an input output ports. Then we have the data bus buffer, which is connected to the bidirectional data bus of the microprocessor, and read and write control logic, it is providing the control signals to the group A control and group B control. So this is the block diagram of 8255. So in this video we studied about the programmable peripheral interface 8255. This 8255, it is acting as a peripheral device which is connected, which is acting as an interface between the microprocessor and some of the input output devices. So whenever microprocessor, it is connected with an it want to communicate with an input output device, then this 8255, it is connected in between it, so it is acting as a programmable peripheral interface. Okay, so we studied the features of 8255, that it's a 40-pin IC. Then we studied the pin diagram, the description of all the pins of 8255, and in the last we studied the block diagram of 8255, describing the functions of all the blocks of the programmable peripheral interface. So I hope that this topic is clear to you. Thank you.